Hello everybody, welcome to section 5.3. We're going to be taking a look at the angle bisector theorem. As you've seen in a previous section, angle bisectors literally split angles in half, and then as a result, when we draw all three of them in a single triangle, they generate a point known as the incenter. While we're not going to be focusing on the incenter as much in this lesson, we're going to focus on what happens because of the angle bisector itself. So we have two pictures here that are based off of this single sentence in the middle. A point is located on the angle bisector of any angle if and only if it is equidistant from the two sides of the angle. So if you look at the picture on the left, because the angle has been bisected and split in half, you do have the congruency marks here for the two angle parts. We know for a fact the length from B to D has to be the same as the length from C to D. It has to be equidistant from one side of the angle to the other side of the angle. Same thing works in reverse. That's why it's an if and only if statement. You have a congruent length from D to B as well as a congruent length from D to C. As a result, we know for a fact this angle A must have been split into two parts that are equal to halves. This sentence and the idea works in both directions. If you have the angle bisected, you know you have the equal distance, or if you know the equal distance, you have the angle bisected. That's the setup in every single problem. You're basically looking for which one do I have, and as a result, which one do I get to then use. So if we take a look at the first two examples here, we're asked to find the value of x in this picture. And if we look closely, we notice that this angle has been split in half. It's been bisected. So as a result, we know it must be the same distance from the sides of the angle. We know for a fact that 4x plus 30 would have to be equal to 9x minus 5. If we subtract the 4x off from both sides, that gives us that 30 is now equal to 5x minus 5. And if we add the 5 over, that'll leave us with one final step from 35 equaling 5x. Simply divide the 5 out, and our missing value of x is in fact 7. And that is all we were asked to find in that particular problem. Same idea in example 2. We have that the distance to the sides of the angle are congruent, both going up to here and over to here. So we know for a fact this angle has to have been bisected. These two parts must be each half of the angle. We know for certain that 5x minus 11 degrees must be the same as 8x minus 41 degrees. And now we're going to go work out the same algebra steps. If we subtract off 5x from both sides, we end up getting that negative 11 is equal to 3x minus 41. If we add the 41 over, we end up reaching the fact that 30 is equal to 3x. So we'll divide out the 3 for the missing value of x in this example to end up becoming 10, which is all we were asked to find, just the value of x in the picture. The only extension you can be offered in these kind of problems is instead of just finding x, what if we go a step further and actually find one of the measurements in the problem? So if we take a look at examples 3 and 4 here, same style setup as the previous two, except notice the question, we're being asked to find the length of a segment or the measurement of one of the angles in the picture. So we still have the same work to do, we just have a little more to do on the back end after we find our value. So if we look here in 3, the angle has been bisected thanks to the marks that are up here at angle B. So as a result, we know that AD and DC have to be the same length. 13x minus 4 will be equal to 8x plus 11. We'll work out the same algebra that we've done in the previous examples. Subtracting 8x off gives me 5x minus 4 equaling 11. Adding the 4 over gives me 5x equaling 15. So if we divide the 5 out, we get that x is 3. But don't make the mistake in this problem. We are not asked for the value of x. We just happen to need it. we have to get the length of AD. So AD was given to be 13x minus 4. If we plug in the 3 that we just found, 13 times 3 minus 4 will give me 39 minus 4, which will end up being 35 units long. Same logic in example 4 here. We already have that the distances to the sides are congruent, so we know for a fact this angle has to have been bisected. These have to be equal to each other. We'll take that 8x minus 32 degrees is the same as 3x plus 3 degrees. And for the fourth time in a row, we're just going to simply work out the algebra. Subtract off the 3x to reach the fact that 5x minus 32 is equal to 3. We'll add the 32 over, and that will give me the fact that 5x is equal to 35, at which point we can divide the 5 out and find that the value of x has to be 7. But again, just like in example 3 over here, that's not the answer to the problem. I've been asked to find the measurement of an angle. XWZ, so if we highlight X going up to W and coming down to Z, it is this angle that is right here, so it is the 8x minus 32. If we go plug in the 7 here, so angle XWZ, 8 times 7 minus 32, that will give us 56 minus 32, which will end up being 24. So we know it ends up being 24 degrees. That's everything out of section 5.3. The basic idea of the angle bisector theorem really is, if you know the angle's been bisected, the sides, the distances to the sides of the angle have to match. Or if you already know the distances to the sides of the angle match, you must have bisected the angle. It works in both directions. If you have any questions on the idea, make sure to ask your teacher, and see everyone in the next lesson.